In the previous video, we constructed a regressor using the k-means algorithm. In this video, we're going to take a look at how to compute the Euclidean distance score between two users. Now that we have sufficient background in machine learning pipelines and nearest neighbours classifiers, let's start the discussion on recommendation engines. In order to build a recommendation engine, we need to define a similarity metric so that we can find users in the database who are similar to a given user. Euclidean distance score is one such metric that we can use to compute this distance between data points. We'll focus on the discussion towards movie recommendation engines. Let's see how to compute the Euclidean score between two users. We start with creating a new Python file, euclideanscore.py, and then import these packages. We will now define a function to compute the Euclidean score between two users. The first step is to check whether the users are present in the database. Next, in order to compute the score, we extract the movies that both users rated. If there are no common movies, then there is no similarity between the users, or at least we cannot compute it given the ratings in the database. For each of the common ratings, we just compute the square root of the sum of squared differences and normalize it so that the score is between 0 and 1. So this is the code we use for computing this. If the ratings are similar, then the sum of squared differences will be very low. Hence the score will become high, which is what we want from this metric. We will use the movieratings.json file as our data file. Let's load it in our main function. Let's now consider two random users and compute the Euclidean distance score. Finally, we add the line of code to print the Euclidean score. Next, we go to our command window to see what happens when we run this code. So now you can see the Euclidean score printed on the screen. In this video, we have computed the Euclidean score for two users for the movies dataset. In the next video, we'll compute the Pearson correlation score.